We have one slightly different situation in this example. In this case, we have a diverging mirror. What makes a diverging mirror different from a converging mirror is that in a diverging mirror, we actually look at the convex side, or the outward rounded side. How does that impact the calculations we have to do? All it does is it changes the focal length to be negative. Because in a diverging mirror, the concave side is away from us, so the focal length is actually on the opposite side of the mirror. And I've identified that here by saying the focal length is negative 5 centimeters. And that mirror produces an image of an object located 15 centimeters from a mirror. This is confusing wording at best. Is that 15 centimeters the distance of the image, or is it the distance of the object? In reality, it is the distance of the object. It produces an image of an object located. Perhaps comma in there would have made it a little nicer to look at, but also part of science is finding out what information you really do have. Another way that we could look at this is if we actually look at the question before we look at the information. What is the distance of the image? That tells us straight away that DI is what we don't know, and that eliminates some of the confusion with this 15 centimeters. That tells us straight out that DO is 15 centimeters. We can go straight to the equation. 1 over DI plus 1 over DO equals 1 over F. DI we don't know. DO 15.0. F 5.0. Sorry, negative 5.0. Work out the fractions. 1 over 15. Didn't mean to put an equal sign there. 1 over 15, 0.066667. 1 over negative 5 is negative 0.2. Subtract 0.066667 from both sides. We have 1 over DI equals negative 0.266667. Take the reciprocal of both sides, DI over 1 on the left, 1 over negative 0.266667 on the right. DI over 1 is DI. 1 over negative 0.266667. We'll take this to sig figs because this is a final answer. We'll go to 2 sig figs, negative 3.8 centimeters. And because DI is negative, it means the image is on the opposite side of the mirror. It means this is a virtual image. Second part of the question, what is the magnification? So how much bigger or how much smaller does the image appear compared to the object? Well, we don't have one equation for magnification. We actually have 2 equations built into one. And we looked at that equation, or those equations, in example 2. It comes out of HI over HO equals negative DI over DO. And we can use either half of that equation to find the magnification. So either magnification equals HI over HO, or the magnification equals negative DI over DO. Depending on the information that we're given and what we have, we do not have HI or HO, neither one of them, so this equation would not be a good one to use. We had DO given to us, and in part A we calculated DI, so this one would be the one that I would go with. So m equals negative di over do. Di, we just found, negative 3.8 centimeters. Now, we have a negative in the equation. We also have a negative from the number, so it's negative 3.8. If you just want to go ahead and change that to positive 3.8, that is absolutely fine. DO is 15.0. Work out the math. Remembering sig figs still, we'll have 2 sig figs. Magnification is 0.25. We could look at this as a percent. We could call it 25%. So the image is 25% of the size as the object. The image is significantly smaller than the object in this case.